Hey everybody, hope you guys are doing great today. We're going to get into lesson 3-2, all right, into our books. So it's finding zeros of these things we call linear functions or linear equations, okay? Let's hop into some new words here. So linear function, should be more familiar with this. Again, a linear function graphs to a straight line. So when we put it into Desmos, we see a straight line here. So that should be good. Parent function. We're going to deal with parent functions for all of our different kinds of functions. Remember, we will have 3 kinds of functions this year. Kind number 1, linear. Kind number 2, exponential. And the third kind is quadratic. So we will have a parent function for each one of those, okay? Our parent function for linear equations, guys, is just this equation here, y equals x. Or sometimes, right, we will see f of x equals x. F of x and y are just synonyms for each other. They mean the same thing. Okay? This is our parent function. Family of graphs. This is kind of what we're going to talk about, parent functions with their family of graphs. So these are, I'll say graphs, right? Or, like equations of graphs. Equations of graphs. My arm's stretching all the way over there. That have one thing in common, one like trait, one characteristic, one feature, okay? So at least one, right? That have one trait in common, right? And we'll talk about what those traits are. Maybe those traits are they're all going in the same direction, right? They're all going, kind of like upward this way, or who knows, okay? Root or zero, right? These are really 2 separate words. So root, 0, I'm going to add a third one in here. Watch this, guys. X-intercept. Okay? These are all the same thing. These are all synonyms for each other. Roots, zeros, x-intercepts. These are all what we call solutions, right? These are solutions, right? If something says find the root, find the 0, find the x-intercept, right, we're talking about what values we could have in this function or this equation that make it true. Okay. Again, more on all this stuff to come, pretty much all chapter long. So some new words. Let's see what all we got to do today. All right. Again, here's what our parent function looks like on a graph, right? So it is just a straight line. It's kind of like that diagonal line that goes from the bottom left to the top right. Again, if you put this on Desmos and you type in f of x equals x, that's what it looks like. You could also type y equals x. That's still what it looks like. Okay? This is a linear function because it graphs to a straight line. Our domain and range on nearly 99.9% of all of our linear functions, their domain and range will be identical, right? It'll be just like this, all real numbers and all real numbers. Okay? All right, don't have anything to erase there. Okay, this one says find the 0 of each linear function by graphing. Okay, I'm just going to draw what the graph looks like, guys. We would go on Desmos and we could do that. And we can find the zeros, which are also known as what, people? Roots, x-intercepts. Yep, those are. So find the zeros of each function. We can do this one of 2 ways. 1, I can graph it. 2, I can solve it algebraically. It's just like solving an equation, which is all we did in chapter 2. We should be awesome at that. Okay? So here's what we got. So I'll show you what this looks like on a graph. Right? Here's this. It's going to go through this number here. It's going to look something like this, guys. Okay? So this is what it looks like on a graph. What is the 0 on it? Well, it's just where does it go through the x-axis, right? And in this case, it goes through the x-axis right here at this point, right? And this is obviously on the x-axis, and it's a negative number, right? Because it's to the left of the origin. Well, what number is that? Well, I can tell you real quickly, it is the number -6, okay? So if we were to write this as an ordered pair, guys, right? This x-intercept is at -6, 0. And if it asks for the 0, it just wants the x value. We know the y value is 0. We just want the x value. So we would say, hey, x equals -6. Okay? What if we solve this with a little bit of math? You guys want to do this? Of course you do. Why wouldn't you? It's fun. All right, here's what we got to do. Here's my function, f of x equals 1/2 x plus 3. To find this algebraically, all we have to do, replace f of x with 0. When you do that, solve the equation for x. So watch what happens here. This turns into 0, okay? Solve this equation for x, right? We should be really good. Move 3 over there, get rid of the 1/2. So subtract 3. You got it, Natalie. 0 minus 3 is -3. Good job. Equals 1/2 x. Again, we could divide by 1/2. That, you know, we typically should be better than that to say, hey, multiplied by its reciprocal, 2/1, which is just the same as the number 2. What do we get? We get the same thing we just got graphically. Okay, so either way works. We need to be good at both. I'd say, honestly, for a case like this, it's just faster to do them algebraically than it is to open up Desmos, type it all in, go through that whole process, okay? But we get the same thing, okay? Here they've given me another one, all right? 1/3 x plus 1. Once again, if we see a graph, right, it's going to go through here. That line's going to look something like that, okay? Again, it's going to go through, we don't need to be that big. It's going to go through my x-axis right here at this point. Again, another negative point, right? It's to the left of 0. This will be at -3. So this is the point -3, 0. Okay. If we wanted to prove it algebraically, again, take this equation, f of x equals 1/3 x plus 1, and set it equal to 0. Okay? Once I'm here, solve the equation for x. Subtract 1, get rid of that 1/3. Subtract 1, 0 minus 1 is -1. That equals 1/3 x. So now go ahead, multiply by its reciprocal, which is just 3, and this will turn into -3. Okay? Boom. Good to go. All right, so that's how we find zeros. Right? Again, we can easily type stuff into Desmos. That's not too challenging. Right? Being able to solve them with a little bit of algebra is where we're after here. Okay? All right. We have a beautiful scenario here with Maria. She can go 420 miles on a 12-gallon tank of gas. Good for her. Here's our equation that models that scenario, right? Guys, eventually we're going to be asked to write this. So we need to start to look at the structure of this. So here's that equation. Hey, I'd like you to do that. There we go. All right, so here's that equation. And they obviously get it from the 420 miles, and we got a 12-gallon tank, okay? Ooh, somebody's calling me. Who could it be? Who cares? Okay. Anyway, this describes the distance. If her fuel mileage is X miles per gallon, right? Do we know her fuel mileage? Not really. Would this go on forever? Oh, geez. Anyway, it says find the zero and describe what it means in the context of the situation. Okay? Identify domain and range and describe their significance. Whoa. Okay. So, guys, a couple things. So, if we were to graph this, okay, here's what it looks like. We're going to start all the way up here, right? And it's just going to go down here. It's going to look just like this. Notice, I only put quadrant 1 in here. Why did I only do quadrant 1? Because, look, guys, we can't have like a negative miles traveled or a negative amount of gas, right, in this car. So quadrant 1 is the only quadrant that makes sense. So first off, find the zero, describe what it means. So find the zero, right? Replace y with 0, solve for x, okay? So 0 equals 420 minus 12x. All right, we're going to move 420 over here. We're going to subtract it. It will turn into negative 420. Okay? I don't think these numbers divide out well. We're going to take that number and we're going to divide it by 12. I get the number, who knows what I get because I can't type into my calculator right. I get the number 35. Okay, this actually does work out well. Sweet. Okay. Okay, So here we go. So there's our 0, right? 35. Again, now, if you think about it graphically, guys, which point is 35? Is it this one up here? Is it this one down here, right? Which one of these points is that 35 number? Lock in your guesses. This one, that's right. So my 0 is 35. Okay? And think about our two variables, right? This is miles that we've got here. This is our, let's see, miles per gallon. Okay? So what does this mean in the context of the problem? So that means our car goes 35 miles for every, you named it, 1 gallon. Okay? We know we have 12 gallons in our car, and in total we went 420 miles. Domain and range here, guys, a little bit different. If you were to put this, okay, into Desmos, here's what it will look like, guys. So it's going to look like this. Okay? That's a terrible arrow. Okay? It literally will look like this. And we would say, hey, what's the domain of this? Well, the domain of that one is all real numbers, and the range is all real numbers. But in real life, guys, can that be the case with this problem? It sure can, right? Because remember, we're just, right, kind of what I hit on earlier, we're just focused on quadrant 1. So my domain for this one, guys, right, if we think left to right, well, it doesn't go any further left than this, and it doesn't get any further right than this number 35. So my domain is really between 0 and 35. Ooh, I'm using fancy interval notation here. Remember, we could do this with a compound inequality as well. 0 less than or equal to x less than or equal to 35. Range, same things, guys. Again, that range over there, all real numbers. But again, how high, how low does it go? Well, it doesn't get any lower than 0. It doesn't get any higher than this point right here, that 420 number. So again, 0 to 420. Okay? Once again, compound inequality, we could use that to write this. Okay? I want to get you familiar with interval notation. Brackets mean we include the number. Parentheses, we don't include it, right? So it's just like greater than or equal to. Have we answered everything? Yes, I think we're good. Whew, that was a lot there. Don't worry, folks, we're getting close to the end. Here's an old equation. You guys want to solve this one real quick? Pause the video if you want. Go ahead and solve it. Not really sure why it's in here. Maybe they're just testing our equation solving ability. But can we solve this? Sure we can. Bring your numbers to one side, variables to the other side. So we'll do that. I'm going to move this over here, so I'm going to add 3x. Okay? Here it goes away. I'm left with this. 6 equals 7. What are you guys thinking? Special case, right? Variable goes away. Somebody said it. Yeah, this is a no solution one, okay? No solution. When you get two numbers that do not equal each other, no solution. If they were, that's the other case. But it's not, so we ain't worried about it. Here's another one. You guys want to solve this one? I don't know why we would. It's another no solution, guys. Look, if we can just look at our two variables and say, hey, they're absolutely identical, right? Their coefficients are identical. We know when I go to bring them together, again, doesn't matter what side we move them on, they're going to cancel out. And all I'm going to be left with is this number here, 4, and that number there, 3. And I know 4 and 3 are not the same number. So therefore, they cannot possibly be the same. Okay? Another word problem for us. We're selling greeting cards this time to raise money for new soccer equipment. Yes. We need something like soccer nets or something, I bet. We paid $115 for all these greeting cards. Now we're going to sell them. This is how we're going to make money. For $1.75. Again, here's this function, right, that represents our profit. Once again, my peeps, eventually we'll have to make these. So start to look at the structure of it. Hey, we sell them for $1.75. I don't know how many I'm selling. That's why we're multiplying it by X, right? That's the number of greeting cards we're selling, right? Whatever amount of money we make here, hopefully we sell a whole bunch of them. We make a ton of money. We have to subtract that from the $115. Why? Because that $115 is what we bought all of those cards for, right? We spent $115 on these things. So we got to sell a whole bunch just to break even, if we think about it that way. Okay, so first things first, find the zero, describe what it means. We can do that, right? We can do that. So set this 0 equals 1.75 x minus 115, okay? So solve this equation for x now. So we're going to add 115, and now we just have to divide by 1.75. I have no idea what number that is in my head. My Kendrick calculator is not working this late in the day. Ooh, I got a bad number. Y'all see that? Ooh, yeah, there you go. Okay, that's what I got. So 65.7. We'll talk about what that means here, I guess. Okay. Remember, so what does this mean? Okay, maybe let's see what this looks like on a graph, right? So once again, I'm just graphing quadrant 1. Well, I can graph more of it, I suppose. Let that line go there. Okay, so guys, this line's going to go all the way down here. It's going to look like this. Okay? So this is the number down here, negative 115. Okay? This number right here, that's the number we just found. That's 65.7 number. So x equals 65.7. All right, what does that mean? Well, that means, guys, remember, this is how much money we're making for our fundraiser, and x is the number of cards, right, that we have to, that I guess in this case that we've sold. Okay? So this 65.7 number really represents how many greeting cards we need to sell in order to have a profit of whatever this number is here on my y-axis. Well, that's 0. So I guess in order for me to break even and not lose any money on this fundraiser, we have to make up that $115 first before we can actually make money. So how many greeting cards is that? Well, it's the 65.7. Okay. After that, hey, now once we sell 66 greeting cards, now we've made up our $115. Now we're making money for our soccer nets. Okay. So once we sell card number, 67 and 68 and 69, now we're making money, right, for our soccer nets. Find the zero, we did it. Describe what it means, we got it. Identify domain and range. Well, once again, folks, think about it. Can we sell negative greeting cards? No, that doesn't make any sense, right? Doesn't make any sense for us to have negative greeting cards. So we can sell 0 greeting cards all the way to, they don't really tell us how many we bought for $115. Maybe we have an infinite number, right, of them. Domain. I'll say it starts at 0. And I guess I'm okay if we put infinity on here for it. That's fine. Okay. What about our range, guys? What about our range? How low does this go? Well, it goes all the way down to that negative $115. And that makes sense because that's that initial amount of money that we spent to buy all those cards. So my range is a negative 115. And once again, they don't really give us how many cards we bought in total, right? If they said, hey, you bought 300 cards, okay, then my domain could only go to 300. And then we would know, hey, if we sell all 300 cards, here's the maximum amount of money that we could make, right? And that would be this number here. But they didn't really tell us that. So I'm perfectly okay with what we have here, all right, for our domain and range. And I believe we've answered all of our questions. So great news. Why is it great, guys? Because we're on our last slide. Get excited. Short day. At least short time seeing me. That's got to make some of you smile out there. Okay? On a trip to his friend's house, Raphael's average speed was this, 45 miles an hour. Was he running? Was he on a bike? What was he doing? That's pretty quick. The distance that Raphael is from his friend's house at a certain moment in the trip is represented by, okay, this lovely equation here. Once again, eventually we'll have to write these. Okay? Where D represents the distance in miles and T is the time in hours. Find the zero of this function. So again, we should start to notice a pattern. We're going to find the zero. We're probably going to describe what it means and find the domain and range. Yeah. Okay? All good. So we're going to find the zero. Again, set your function equal to 0 to find a 0. Okay? Make sure your t's look like t's, people. Subtract 150 over here. So now it's negative 150 equals negative 45t. Once again, don't think we're going to get a good number here. Are we? Sure aren't. Bam. Right? I get 3 1/3. T equals 3.3. Repeating. Okay? So describe what this means. Well, again, I'll give you a quick graph. So guys, here's my graph. Again, it's going to start at 150, right? That's going to be all the way up here, 150, right? And it's going like so until we get to here. Ooh, bad news. Hang tight. I'll make this come. Ooh, nope, that didn't work either. I'll make it come back. You just wait. Kabam, I'm back. We still don't have a screen though. Whatever, I think my computer died, so the screen went away, but we're on the end of the problem, so we'll tackle it from here, folks. All right, so again, what does this mean, right? So guys, this is our 150 miles away, right? We are traveling at 45 miles an hour, and how long does it take? Well, it takes us that come back, Ben, there you go. It takes us 3.3 hours to make it to our friend's house, right? We were traveling at 45 miles an hour. We were 150 miles away. Once again, domain and range, I know it didn't ask for it, right? But our domain here, right? Again, we can't have negative time, so my domain would be from what? From 0 to that 3.3 hours, right? Because after that, we're already there, right? We're not going anywhere else. We're there, right? What is my range, right? Up and down. Well, eventually we get to 0 miles away, right? And the furthest we were away is 150. So from 0 to 150 is my range. Okay. So anyway, so guys, there we go. Sorry for the hiccup here at the end. All good. We just roll with the punches. That should do it though for 3-2, right? So we've got our book work. We have quizzes. Hopefully we'll get some homework. So hope you guys had fun. Hope you learned a little bit about zeros and roots. We'll get into parent functions and family of graphs here very, very soon. See you guys.